function of a diode is to allow current to flow in only one direction. The manufacturer of silicon diodes uses 3 consecutive elements in the periodic table: aluminium, silicon and phosphorus. The reason for this is to engineer the fall of an electron into a hole. In the case of a silicon diode, a phosphorus electron falls into a hole created by an aluminium atom. There are 3 yellow electrons in the outer shell of aluminium, 4 in silicon and 5 in phosphorus. We can see this structure more easily if we use atomic models. Injecting an aluminium atom into a silicon substrate leaves a gap into which an adjacent electron can fall. These gaps are called holes and move in the opposite direction to electrons. Adding phosphorus to the silicon substrate produces a free electron. This makes the substrate conductive and the electron can move under the influence of a charge. The 2 types of material are called N-type and P-type, with the N-type carrying an extra electron. The p-n junction allows holes and electrons to combine in a very narrow region around the join, called the depletion region. Reverse biasing causes the depletion region to become wider, so no further recombination of holes and electrons can happen and no further current can flow. Forward biasing the device greatly assists the hole electron recombination process and current flows easily. Notice that electrons flow in only one direction in both P and N-type material. The diode biasing polarity can be remembered if we imagine the diode symbol is a mouse. Negative on the nose makes the diode conduct. Notice that these 3 lead enclosures are perfectly clear, but the colour of each lead is different. This colour difference is due to the movement of electrons within the atom. When an electron falls into a lower atomic level, radiation is emitted to conserve energy. The greater the fall in energy, the shorter the wavelength of radiation and the higher its frequency. Blue light has a short wavelength and red light has a longer one. The radiation emitted by a silicon diode is not visible since it falls in the infrared region. However, using gallium causes the radiation to fall in the visible spectrum. That is, the diode emits light. In this green lead, the depletion region is formed in the cup-like shape at the top of the dome. The piece of fine wire within the dome joins the cathode and anode, making the p-n junction visible. Each time an electron falls into a hole at the junction, a photon is emitted, and we observe this as green light. Reverse biasing the device widens the depletion region, stopping both current flow and light production.